it an experience or maybe my opinion or my views? This speaks to statistics, especially in the field of psychology. Um, Most people are kind of nervous, or is this scared? I don't know which word to use even. Anxious, scared, or nervous. When it comes to statistics in the field, so people don't expect that we have statistics. I was speaking to someone even that most of my students, I've realized that I'm presenting a paper actually on this. So most students, they don't expect to have um, statistics in the field. Like even if you, I know most of the institutions, uh, they, they have um, statistics from second year in the BA psychology. If you taking psychology modules, the 1, 2, 3, 3, 2, 1, something like that, PSY. So there is introduction to research methods and statistics, and there is research methods and statistics, whereby the other focus on descriptive statistics, the other inferential statistics. And then when you think you are done, when you get to honors, you also like, okay, we have research methods and statistics, but excuse me, what's happening now? I want to become a clinical psychologist. I want to become a counseling psychologist. What is all this? But I think research, not I think, but actually research is very important in the field, because we are living in a world that we don't fully understand. So we need to kind of inquire and acquire knowledge using credible scientific methods. So in the process, in most of the cases in our field, we end up making use of quantitative research approaches. So we need analysis for that. And then said, but I don't know what to do, which technique to use in the statistics space. I'm speaking for statistics to statistics. So in most cases, there are cross-sectional kind of designs, experimental designs. Those are the two major and common ones. And in case of and when experimental designs are used, just to compare, maybe to check if there's a difference, if there's a significant change after an intervention. So in most cases, that's where t-test comes in, that's where ANOVA comes in. They can be sub of whatever ANOVA, like the Factorial ANOVA, ANCOVA, MANOVA, but actually the main part is, what do you intend to do? So ask yourself, okay, should I run correlation, regression, chi-square, t-test? Yeah, those are the major ones. You should be able to ask yourself, when, in what instances or cases should we run whatever that I've mentioned, or correlation, t-test, chi-square. So, and also it comes to maybe the difficult in the introduction phase, and part of it is that we have the descriptive statistics. Sometimes we are required to make use of the manual calculations. I think that's what makes students like, okay, hold on. But I think it makes sense to be able to know where the formulas are coming in. Although we can do it using computers like the Excel, I don't know how you pronounce it, the SPSS, among others. But I think it's important. I believe that because I have taught like in the previous how many years? 7 years. And I think it is important that we know where the formula is coming from. Like we have data scales of measurements, and we have the frequency distributions. There is a reason why we are teaching all that, because you should maybe be able to understand, why are we doing that even? Why are we measuring the central tendency? And okay, we are done with the central tendency. Why are we then going to the variability stuff? And after variability, but like, why is it? What's these Z scores for standardization? And then the probability using the unit. Most of the students don't like those tables in the last pages or the back of the textbook, but we use that just to identify the chances or probability of something happening. But anyway, in the normal distribution, and then there's hypothesis testing steps. So obviously, it's not enough to describe a sample, but we would want to assess and check and test if the same relationship difference exists in the population. So the central theorem stuff. And then that is when it comes now. That's what is, let's say you are in an honors level, you should just know whatever question we have, what is the technique, that is most appropriate for such. So if you are interested in relationships, if the data has been measured at whatever level that is acceptable. Continuous level, that's with the correlation. For prediction, that's regression. If you have a number of predictor variables, you have multiple regression. And then if chi-square sometimes is pushed in, but actually it's a non-parametric, but let's leave it for now. So when the data has been measured at a categorical level, that's chi-square comes in there. And then, like what I've just said before, the t-test, that's where the comes from experimental designs, and the ANOVA when we have more than 2 groups or conditions. So at least if you know that, you are kind of a step ahead and know you want to do. But also you should know at honors and advanced, we are required and requested to test for assumptions if they were not violated. So there are major assumptions that speaks to most of the techniques, like there's the normal distribution, independent observation, you check for outliers. So those are some of the things, but an advantage of SPSS, you can test for those at once as you running your analysis. But I think I have a video, I'll check for it though. If I have a video like that, just